What happens if you never sleep? Have you ever wondered what would happen if you simply stopped sleeping? Not for one night, not for two. What if you stayed awake for an entire week? At first, it might seem like nothing more than an inconvenience. You'd feel tired, maybe drink another cup of coffee and push through the day. But beneath the surface, something much more terrifying would be unfolding. Your brain would slowly begin to lose its grip on reality. Your immune system would weaken. Your heart would work harder than it should. Your emotions would become impossible to control. Eventually, your own mind could turn against you. Sleep isn't just a time when your body rests. It's one of the most important biological processes keeping you alive. Scientists now believe that every organ in your body depends on sleep in ways we're still discovering. And here's the frightening part. You can survive for weeks without food. You can survive for days without water. But without sleep, your brain begins to fail long before your body does. In today's episode, we'll explore what really happens inside the human body hour by hour as sleep disappears. We'll examine famous scientific experiments, uncover shocking medical discoveries, and answer one haunting question. Can a human actually die from never sleeping? Let's begin. Part 1. Why do humans need sleep? For thousands of years, people believed sleep was simply the brain shutting down for the night. Modern science has revealed something completely different. Your brain is actually incredibly active while you sleep. Imagine an entire city. During the day, traffic fills every street, factories operate non-stop. Businesses open their doors. Garbage piles up faster than sanitation workers can collect it. Eventually, the city becomes overwhelmed. Night arrives. The streets empty. Cleaning crews begin their work. Repairs take place. Power systems are inspected. Everything prepares for another busy day. Your brain works almost exactly the same way. Every second you're awake, billions of neurons communicate using tiny electrical signals. They create memories, solve problems, regulate emotions, and keep your organs functioning. But all that activity creates waste. Scientists discovered a remarkable cleaning system known as the glymphatic system. While you're asleep, spaces between brain cells expand, allowing cerebrospinal fluid to wash through the brain like an overnight cleaning crew. This process removes harmful waste proteins that build up throughout the day. Some of these proteins, including beta amyloid, have been linked to Alzheimer's disease when they accumulate over many years. In other words, sleeping literally helps clean your brain. But that's only one part of the story. During deep sleep, your brain decides which memories deserve to stay. Everything you learn today, names, conversations, skills, even emotional experiences, is carefully sorted. Important memories become stronger. Unimportant information is quietly erased. Without sleep, this process begins to fail. That's why students who stay awake all night studying often perform worse than those who actually sleep before an exam. Their brains never had the chance to organize what they learned. Sleep also regulates nearly every hormone in your body. Growth hormone, insulin, cortisol, leptin, ghrelin. These chemicals control everything from hunger and metabolism to stress and muscle repair. Miss just one night of sleep and these delicate systems begin falling out of balance. You become hungrier. You crave sugary foods. Your body becomes less sensitive to insulin. Stress hormones rise, blood pressure increases, even your reaction time slows dramatically. Researchers have found that staying awake for about 20 hours can impair your performance almost as much as being legally drunk. That means driving after a sleepless night can be just as dangerous as driving under the influence of alcohol. Yet millions of people do exactly that every single day. Sleep isn't optional. It's maintenance for the most complex machine in the known universe. your brain. And when that maintenance stops, the countdown begins. Part 2. The first 24 hours without sleep. Imagine waking up on Monday morning. You go to work. You stay awake all day. Normally, you'd head to bed around 11 p.m. Instead, you keep going. Midnight arrives, then 2 a.m., then 4 a.m. At first, you simply feel tired. Your eyelids grow heavier. Yawning becomes constant. Concentration fades. Simple tasks suddenly require enormous effort. Inside your brain, however, something fascinating is happening. Your body follows an internal biological clock known as the circadian rhythm. This clock is controlled by a tiny region deep inside the brain called the suprachiasmatic nucleus. It uses sunlight to determine when you should be awake and when you should sleep. As darkness continues, your brain releases melatonin. It expects you to be asleep, but you're still awake. Now, two powerful forces begin fighting each other. Your circadian rhythm tries to keep you alert because morning is approaching. Meanwhile, sleep pressure, caused by a chemical called adenosine, continues building inside your brain. The longer you're awake, the greater that pressure becomes. Eventually, it feels almost impossible to resist. By the time you've gone 18 to 20 hours without sleep, your attention begins breaking apart. You read the same sentence 3 times, forget why you entered a room, lose your train of thought in the middle of a conversation. Reaction times become dangerously slow. This is why fatigue contributes to thousands of traffic accidents every year. But one of the strangest effects is something called microsleep. A microsleep lasts only a few seconds. Your eyes may remain open. You might even appear awake. Yet parts of your brain briefly shut down without your permission. Imagine driving on the highway at 70 miles per hour for just 4 seconds. Your brain switches off. You've traveled the length of a football field completely unconscious. Most people never even realize it happened. As morning arrives after your first sleepless night, you may actually experience a brief burst of energy. Many people mistake this for recovery. It isn't. Stress hormones like cortisol temporarily increase, masking your exhaustion. But underneath that temporary boost, your brain is already beginning to struggle, and things are about to become much, much worse. What happens if you never sleep? Intro. Have you ever wondered what would happen if you simply stopped sleeping? Not for one night, not for 2. What if you stayed awake for an entire week? At first, it might seem like nothing more than an inconvenience. You'd feel tired, maybe drink another cup of coffee and push through the day. But beneath the surface, something much more terrifying would be unfolding. Your brain would slowly begin to lose its grip on reality. Your immune system would weaken. Your heart would work harder than it should. Your emotions would become impossible to control. Eventually, your own mind could turn against you. Sleep isn't just a time when your body rests. It's one of the most important biological processes keeping you alive. Scientists now believe that every organ in your body depends on sleep in ways we're still discovering. And here's the frightening part. You can survive for weeks without food. You can survive for days without water. But without sleep, your brain begins to fail long before your body does. In today's episode, we'll explore what really happens inside the human body hour by hour as sleep disappears. We'll examine famous scientific experiments, uncover shocking medical discoveries, and answer one haunting question. Can a human actually die from never sleeping? Let's begin. Part 1. Why do humans need sleep? For thousands of years, people believed sleep was simply the brain shutting down for the night. Modern science has revealed something completely different. Your brain is actually incredibly active while you sleep. Imagine an entire city. During the day, traffic fills every street, factories operate non-stop, businesses open their doors, Garbage piles up faster than sanitation workers can collect it. Eventually, the city becomes overwhelmed. Night arrives. The streets empty. Cleaning crews begin their work. Repairs take place. Power systems are inspected. Everything prepares for another busy day. Your brain works almost exactly the same way. Every second you're awake, billions of neurons communicate using tiny electrical signals. They create memories, solve problems, regulate emotions, and keep your organs functioning. But all that activity creates waste. Scientists discovered a remarkable cleaning system known as the glymphatic system. While you're asleep, spaces between brain cells expand, allowing cerebrospinal fluid to wash through the brain like an overnight cleaning crew. This process removes harmful waste proteins that build up throughout the day. Some of these proteins, including beta amyloid, have been linked to Alzheimer's disease when they accumulate over many years. In other words, sleeping literally helps clean your brain. But that's only one part of the story. During deep sleep, your brain decides which memories deserve to stay. Everything you learn today, names, conversations, skills, even emotional experiences, is carefully sorted. Important memories become stronger. Unimportant information is quietly erased. Without sleep, this process begins to fail. That's why students who stay awake all night studying often perform worse than those who actually sleep before an exam. Their brains never had the chance to organize what they learned. Sleep also regulates nearly every hormone in your body. Growth hormone, insulin, cortisol, leptin, ghrelin. These chemicals control everything from hunger and metabolism to stress and muscle repair. Miss just one night of sleep and these delicate systems begin falling out of balance. You become hungrier. You crave sugary foods. Your body becomes less sensitive to insulin. Stress hormones rise, blood pressure increases, even your reaction time slows dramatically. Researchers have found that staying awake for about 20 hours can impair your performance almost as much as being legally drunk. That means driving after a sleepless night can be just as dangerous as driving under the influence of alcohol. Yet millions of people do exactly that every single day. Sleep isn't optional. It's maintenance for the most complex machine in the known universe, your brain. And when that maintenance stops, the countdown begins. Part 2. The first 24 hours without sleep. Imagine waking up on Monday morning. You go to work. You stay awake all day. Normally, you'd head to bed around 11 p.m. Instead, you keep going. Midnight arrives, then 2 a.m., then 4 a.m. At first, you simply feel tired. Your eyelids grow heavier. Yawning becomes constant. Concentration fades. Simple tasks suddenly require enormous effort. Inside your brain, however, something fascinating is happening. Your body follows an internal biological clock known as the circadian rhythm. This clock is controlled by a tiny region deep inside the brain called the suprachiasmatic nucleus. It uses sunlight to determine when you should be awake and when you should sleep. As darkness continues, your brain releases melatonin. It expects you to be asleep, but you're still awake. Now, two powerful forces begin fighting each other. Your circadian rhythm tries to keep you alert because morning is approaching. Meanwhile, sleep pressure, caused by a chemical called adenosine, continues building inside your brain. The longer you're awake, the greater that pressure becomes. Eventually, it feels almost impossible to resist. By the time you've gone 18 to 20 hours without sleep, your attention begins breaking apart. You read the same sentence 3 times, forget why you entered a room, lose your train of thought in the middle of a conversation. Reaction times become dangerously slow. This is why fatigue contributes to thousands of traffic accidents every year. But one of the strangest effects is something called microsleep. A microsleep lasts only a few seconds. Your eyes may remain open. You might even appear awake. Yet parts of your brain briefly shut down without your permission. Imagine driving on the highway at 70 miles per hour for just 4 seconds. Your brain switches off. You've traveled the length of a football field completely unconscious. Most people never even realize it happened. As morning arrives after your first sleepless night, you may actually experience a brief burst of energy. Many people mistake this for recovery. It isn't. Stress hormones like cortisol temporarily increase, masking your exhaustion. But underneath that temporary boost, your brain is already beginning to struggle, and things are about to become much, much worse. Part 4. 72 hours without sleep. When the mind begins to fall apart, 3 days, 72 hours. By now, your body isn't simply asking for sleep anymore, it's demanding it. Every biological system is under enormous strain, and your brain is struggling to distinguish reality from imagination. This is where sleep deprivation becomes genuinely frightening. Hallucinations begin. At first, the hallucinations are subtle. You catch movement in your peripheral vision. You think someone is standing behind you. You hear footsteps in an empty room. Then they become impossible to ignore. People who have stayed awake this long have reported seeing insects crawling across walls that weren't really there. Others describe hearing voices, music, or conversations that never happened. Some believe strangers are following them. Others become convinced that their friends are plotting against them. To the sleep-deprived brain, these experiences feel completely real. That's because your brain is no longer processing information correctly. Instead of accurately interpreting the world around you, it begins filling in missing pieces with its own imagination. In a sense, you're starting to dream while still awake. Losing track of reality. As sleep deprivation continues, confusion becomes severe. You may forget where you are, lose track of time, repeat the same question over and over without realizing it, hold conversations that make no logical sense. Your thoughts become fragmented. Simple tasks that once took seconds now feel impossible. Imagine trying to tie your shoes, but forgetting how shoelaces work. Trying to read a sentence, but the words no longer seem connected. Looking at a clock, but being unable to understand what the numbers mean. This isn't laziness. It's your brain beginning to shut down higher-level thinking in order to conserve energy. The body is falling behind. Meanwhile, the damage isn't limited to your mind. Your immune system has become significantly weaker. Your body's inflammatory response increases. Stress hormones remain elevated. Blood pressure stays high. Heart rate becomes more irregular. Muscles become slower to respond. Balance deteriorates. Your reaction time becomes dangerously delayed. At this stage, operating a vehicle or heavy machinery would be extraordinarily dangerous. Even walking down a flight of stairs could become risky. Your body is exhausted, but your brain can no longer reliably tell you what's safe. The dangerous state called microsleep. One of the strangest effects now becomes almost impossible to avoid: microsleeps. Earlier they lasted only a few seconds, now they happen more often, and they last longer. You may be speaking to someone, then suddenly stop in the middle of a sentence. For several seconds, your brain essentially falls asleep. Then you wake up again, often without realizing anything happened. Researchers using brain scans have discovered something astonishing. Different parts of the brain can actually fall asleep independently while other regions remain awake. Imagine a city where random neighborhoods lose electricity one at a time. Traffic lights stop working. Hospitals lose power. Communication breaks down. Eventually, the entire city begins to fail. That's exactly what's happening inside your brain. When paranoia takes over by the third day, some people begin experiencing paranoia. They become convinced that others are watching them, that someone is following them, that ordinary conversations contain hidden messages. These beliefs can become so convincing that reasoning no longer helps. Doctors have compared severe sleep deprivation to temporary psychosis because the symptoms can look remarkably similar. Fortunately, in most healthy people, these symptoms disappear after proper sleep. But until that sleep happens, reality itself becomes unreliable. Can you actually stay awake forever? Surprisingly, no. The human brain has evolved powerful survival mechanisms. Even if someone desperately tries to remain awake, the brain will eventually force brief episodes of sleep. Sometimes they last only a second, sometimes several seconds. The person may not even notice. These involuntary shutdowns are the brain's last attempt to protect itself. It's a biological emergency response, because without sleep, the brain simply cannot continue functioning normally. But this raises an even bigger question. If the brain fights so hard to make us sleep, could a person actually die from never sleeping? The answer is more disturbing than most people realize. Part 5. Can you actually die from lack of sleep? It's one of the most unsettling questions in medicine. Can sleep deprivation actually kill you? At first glance, the answer seems obvious. After all, people have stayed awake for several days and survived. Randy Gardner recovered. Many military personnel have endured extreme sleep deprivation. Doctors working long emergency shifts sometimes function with very little sleep. So, if people can survive days without sleeping, why is sleep considered essential for life? The answer lies in the difference between temporary sleep deprivation and the complete inability to sleep. And that difference has led scientists to one of the rarest and most terrifying diseases ever discovered. The disease that steals sleep forever. Imagine slowly losing the ability to fall asleep, not because you're stressed, not because you're drinking too much coffee, but because your brain literally forgets how to sleep. No medication works. No sleeping pill helps. No amount of exhaustion can force your body into restful sleep. This condition exists. It's called Fatal Familial Insomnia, or FFI. FFI is an incredibly rare inherited brain disorder caused by a mutation in the PRNP gene. That mutation creates abnormal proteins known as prions, which slowly damage a region of the brain called the thalamus. The thalamus acts like a central relay station, helping regulate consciousness, sensory information, and, most importantly, the sleep-wake cycle. As the disease progresses, the thalamus becomes increasingly damaged. Patients begin sleeping less and less. Weeks later, their sleep becomes fragmented, then almost disappears entirely. But insomnia is only the beginning. The slow collapse. As sleep vanishes, the rest of the body begins to fail. Patients often experience severe anxiety, rapid weight loss, muscle twitching, high blood pressure, difficulty speaking. Memory loss, hallucinations, confusion, loss of coordination. Eventually, they become unable to perform even the simplest daily activities. The brain loses its ability to regulate basic functions that healthy people never think about. The disease is relentlessly progressive, and tragically, there is currently no cure. Most patients die within months to a few years after symptoms begin. What's important to understand is that these patients don't die simply because they're tired. They die because the brain damage that prevents sleep also destroys the systems necessary to keep the body alive. Sleep loss is one devastating symptom of a much larger neurological catastrophe. What about healthy people? This naturally raises another question. If a healthy person never slept, would the lack of sleep alone eventually become fatal? Scientists don't know for certain, And for obvious ethical reasons, no experiment has ever pushed a healthy human to that point. However, animal studies provide disturbing clues. Researchers prevented rats from sleeping for extended periods. Despite having access to food and water, the animals eventually developed severe immune dysfunction, metabolic collapse, loss of body temperature control, organ damage, and ultimately died. These findings strongly suggest that sleep itself performs biological functions so essential that life cannot continue indefinitely without it. Exactly which function fails first remains one of neuroscience's greatest mysteries. The silent damage most people ignore. Fortunately, very few people experience total sleep deprivation, but millimeting almost a chronic sleep deprivation. Sleeping 5 hours instead of 7, 6 hours instead of 8, night after night, month after month, year after year. Type 2 diabetes, obesity, depression, anxiety disorders, weakened immunity, stroke, dementia. The damage accumulates slowly, making it easy to underestimate. Many people proudly say, "I only need 4 hours of sleep." But scientists have found that people who are chronically sleep-deprived often become poor judges of their own impairment. They believe they're functioning normally, even while objective testing shows significant declines in memory, attention, reaction time, and decision-making. In other words, one of the first things sleep deprivation steals is your ability to recognize that you're sleep-deprived. And that may be its most dangerous trick of all. Coming next, in the final chapter, we'll explore why modern society is experiencing a growing sleep crisis, what science says about getting truly restorative sleep, and the simple habits that can protect one of the most powerful systems your body has. The modern sleep crisis and why sleep may be the best medicine. Today, most people aren't trying to stay awake for 3 days. They're doing something far more common: sleeping just a little less than they should. One late-night TV show, a few extra emails, an hour of scrolling through social media, another episode, one more video, another alarm set for early morning. It doesn't feel dangerous. In fact, modern society often celebrates people who sacrifice sleep. We admire the entrepreneur who works all night, the student who studies until sunrise, the employee who proudly says, "I'll sleep when I'm dead." But biology doesn't negotiate. Your brain doesn't care about deadlines. Your heart doesn't care about your social media feed. And your body never stops keeping score. Your brain keeps a sleep debt. Think of sleep like a bank account. Every night you get enough high-quality sleep, you're making a deposit. Every night you cut your sleep short, you're making a withdrawal. Miss 1 hour tonight, another tomorrow, and another the next day. Soon you're carrying a growing sleep debt. Unlike money, this debt can't always be repaid with one long weekend of sleeping in. Some of the cognitive effects recover quickly. Others may take days or even longer to fully normalize. This is why many people wake up after a vacation feeling mentally refreshed. For the first time in months, their brain finally had enough time to repair itself. What science says about healthy sleep: experts generally recommend that most adults get 7 to 9 hours of sleep each night. But it's not just about the number of hours. Quality matters just as much. Healthy sleep follows a cycle. You move through light sleep, deep sleep, and REM sleep, where vivid dreaming often occurs. Each stage serves a different purpose. Deep sleep helps restore the body, repair tissues, strengthen the immune system, and release important hormones. REM sleep plays a major role in learning, emotional regulation, creativity, and memory. When these cycles are repeatedly interrupted, your brain loses some of the benefits, even if you spend enough total hours in bed. Simple habits that protect your sleep. Fortunately, improving sleep doesn't always require expensive treatments. Small habits can make a remarkable difference. Try going to bed and waking up at the same time every day, even on weekends. Your brain loves consistency. Reduce bright screens before bedtime. The blue light from phones, tablets, and laptops can delay the release of melatonin, making it harder to fall asleep. Keep your bedroom cool, dark, and quiet. Avoid heavy meals, nicotine, and excessive caffeine late in the day. Regular physical activity can also improve sleep quality, but intense exercise right before bed may keep some people awake. And perhaps most importantly, treat sleep as a necessity, not a luxury. The average person will spend nearly 1/3 of their life asleep. At first, that may sound like time lost, but science tells a very different story. Sleep is when your brain cleans itself, when memories are organized, when your immune system grows stronger, when hormones are balanced, when muscles recover, when your heart gets a chance to rest. Far from being wasted time, sleep is the invisible foundation that makes every waking moment possible. The next time you're tempted to sacrifice sleep for just one more hour of work, one more movie, or one more scroll through your phone, remember this: you can ignore sleep for a while, but eventually, sleep will demand its turn. Because in the end, sleep isn't a sign of weakness. It's one of the most extraordinary survival mechanisms evolution has ever created. If you enjoyed this deep dive into the science of the human body, don't forget to like this video. Subscribe to the channel and turn on notifications so you never miss our next exploration into the mysteries of science, history, and the human mind. Until next time, sleep well. Your brain is counting on it.